afternoon. Okay, so I guess my role as the lead speaker is to set the stage, and so personally I like to sort of set the stage geographically. So let's look at what we're talking about here. We're going to be focused on the prairie ecozone of Canada, which is the yellow zone there is the prairie ecozone of Canada, and according to our National Ecological Land Classification, the prairie ecozone is divided into a number of ecoregions, and so here in Saskatoon we're in the moist mixed grassland. The moister part is the aspen parkland, drier part is the mixed grassland ecoregion, and then we have these montane ecoregions, the foothills fescue and the cypress upland. I'm cheating a little bit. This pink color here is the tall grass prairie, which is not part of the National Ecological Land Classification. I wish it had been, but so I found a good map of the tall grass prairie to superimpose on top of that. So those ecoregions, of course, are driven 99% by climate, and so here's a map of the climatic moisture index for the prairie ecozone, and this is precipitation minus potential evapotranspiration. And so we can see that the mixed grassland is associated with the driest climates, and then those other ecoregions are in progressively moister climates, and then beyond the boundaries we get into forest where the climate is moist enough to support forest. So rough boundaries here in terms of this climatic moisture index. If we have positive numbers for the CMI, we're in the forest, 0 to minus 175 aspen parkland, and so on down to the drier mixed grassland ecoregion. So here's just a couple of pictures. Here's aspen parkland, the typical mosaic of aspen groves, and at least in our part of the aspen parkland, fescue prairie is the potential grassland community. Moist mixed grassland, still a productive grassland, but with a lot less tree cover, and then our driest mixed grassland ecoregion, and species composition changes accordingly. Here's the cypress upland, and of course this is a montane ecosystem resulting from altitude. Okay, and then let's remember that those ecoregions are not uniform. Within ecoregions we talk about ecosites, which depend on topography, soil, moisture regime, salinity, and so this is the classification of ecosites that we use here in Saskatchewan. It's pretty similar to the Alberta classification with some differences, and Manitoba, they don't quite have one yet, and we're kind of working on that, but I think it'll look sort of similar to this eventually. And so I'll just run through a few. Oh, here's our map of ecosites for Saskatchewan, for the prairie ecozone part of Saskatchewan. And one thing I want to point out is that predominant brown color. Okay, so the most widespread ecosite in our grassland is what we call the loam ecosite. So well-drained uplands with loamy textured soils accounts for 40 or 50% of our grassland, and I think probably Alberta's a little higher in salinity, or the burnouts, I guess, vary, but
that's right.
pretty high in loamy too, I'm sure. Right? Yeah. So I'll just a few pictures just to get at this idea of ecosite variation. So these are all in the mixed grassland ecoregion, so a dry climate basically. And here's our loam ecosite, and a lot of our loam ecosite is on these rolling morainal deposits, so that you see rocks and you see fine soil between the rocks, and you usually wind up with a loamy texture, soil texture. Here's our sand ecosite. Often they're glacial fluvial plains with sand material, and I'm trying to show the differences in species composition. So needle and thread and northern wheatgrass on the loam, needle and thread and sandgrass on the sand. Here's our clay ecosite, which is it's kind of a museum piece. There's virtually all of it's wheat fields now, but there's a little bit of clay ecosite in a few places, and often dominated by wheatgrasses. Dunes ecosite, needle and thread and sandgrass, and in the drier parts we've got sagebrush there. Thin ecosite is these steep slopes, and they're called thin because you have high natural rates of soil erosion, and so the soil profile is often sort of truncated by constant soil removal. And then in the background is our Badlands ecosite, which we see in quite a few places in the south, basically very sparsely vegetated grasslands. Solonetsik, or they call it burnout range site in Alberta, we've got a lot of these high sodium soils, and so they tend to develop this dense hard pan layer, and often you get these eroded pits in it. That's where the name burnout comes from. And then some of our moisture ecosites. So here we have a stream floodplain, call this overflow ecosite, and in the south it's often sagebrush. And then progressively wetter. Here's a wet meadow with sedges and narrow reedgrass. So I just like to keep in mind that whole, kind of the geographic range of grasslands that are out there. That's what we're talking about. I guess the big question in a conference about status and trends is what are the threats to our native prairie, and so I'll go through each of these and try to talk a little bit about them. Clearly, agricultural conversion is by far, I would say, the biggest threat to our native prairie. And how much have we lost already? Well, here's a nice map that was put together by the Nature Conservancy. Riley et al. Was 2007, I think, was the publication. Yeah. So they've taken data from the 3 provinces and tried to put it together to give a picture. And the green color shows the remaining native grassland. That's what it's trying to show. And of course, the white is mostly cropland. I think the orange over here is hardwood forest, but it gives you a picture of the amount of grassland that's left. And here it is in terms of numbers. Basically, overall, it's showing about 25% of the prairie ecozone still in grassland. And of course it varies quite a bit among ecoregions, with the mixed grassland having a much higher percentage, 41%, compared to the moist mixed and the aspen parkland. Moisture climate's more conducive to annual cultivation. This is one source of data, and the map that I showed you before is based on remote sensing, basically. So it was sort of different in each province, but basically remote sensing data. So how do we know how good that is? Obviously, there's sources of error and so on. So we brought in another independent source of data, which is the Census of Agriculture. So every 5 years, they send out census forms to every agricultural producer, and they're supposed to report on how much cropland they have and how much prairie, native range and how much tame range and so on they have. And so it's possible to roll up all those statistics and get an idea of what percentage, at least of the farmland, is in native prairie. And so when we do that, we wind up with 23% from the census and 25% from remote sensing data. So we feel a little bit better about that number, having the same sort of number from 2 different sources. Like I say, there are sources of error in both sets of data. One problem with the census, of course, is that it's only agricultural land. So there is some land, like protected areas and so on, that may not be included. So it could have a bias for that reason. In the remote sensing data, probably the biggest issue there is accurate identification of native prairie. And of course, I think usually what people find is one of the hardest things is separating native prairie from tame pasture consistently. So, sources of error, but we feel a little bit better about this number, having 2 sources of information. That's based as of the 1990s. We have census data, of course, more recently, but I tried to match it up with the 90s remote sensing data that was used in the previous publication. I'll show you some of our big ecoregions. Here's mixed grassland. The yellow, of course, is grassland. Here's the moist mixed grassland, a moisture climate, and here's the aspen parkland. So that shows we've got a lot more grassland in the mixed grassland ecoregion, the drier climate that's somewhat less suitable for annual cultivation. Now, how has this changed over the years, right? Well, this is again from the Census of Agriculture, and the span is from 71 to 2006. And the green line here at the top is the trend from year to year in the percentage of farmland that's in native pasture. And So it started out a little above 25% and ended up a little below 25%. So over that 35 years, it's a fairly small decrease. That's what it looks like from those data. I'm also showing tame pasture on here just for comparison. And over that same time period, tame pasture has actually increased a bit more than the native prairie has decreased. And of course, a lot of that new tame pasture was on previously cultivated land. So that's the reason for the difference. So, you know, that doesn't look like a very fast decrease in the past 35 years. Can we push it back further? And I don't have a complete analysis of that, but I've got a sort of a partial analysis going back to 1941. This came from a publication that Bob Copeland, who was our grassland expert here in this department in the Department of Crop Science and Plant Ecology for many years, looked at this, and I've just kind of extended his data into the present. And so this gives us kind of a longer time frame. There's, for some of the census divisions in mixed prairie in Saskatchewan, back in the 40s it was up about 42%, 43% grassland, down to this 25% now. I guess it's down to 30 in this particular set of census divisions. So that pushes a little bit further back. So obviously there was more change from 1940 to about, what's this, 1980 or so, than since then, you know, faster decrease. But, you know, if you think that if we go back to 1880, it was all grassland, right? Virtually the entire landscape was grassland, except for some percentage of wetlands, I guess. And so from about 1880 to 1940, it had to go from 90 or 95% down to 40 or 45%. So the biggest decrease was early in the past century. So that's kind of looking at the total amount of grassland that we have. Now, another big issue is that we don't have those patches of grassland all in one block, right? It's in a lot of little blocks, and so fragmentation is the term that's used among conservation biologists to describe this situation. And so here's a chunk of southwestern Manitoba, and the yellow is native prairie, and what it's showing, of course, is that the native prairie out there is fragmented into a lot of little patches, most of it. Here's an analysis that was done by Paul James here in Saskatchewan, and what this is showing is different sizes of grassland patches. So starting from the ones that are less than 10 hectares up to the ones that are more than 1,000 hectares. And basically what it's showing is that, you know, by far most grassland patches are little ones, right? And there's only a few big ones, you know, so that's this concept of fragmentation. Why is this important? Well, if you're interested in conservation, there's lots of research out there showing that those big patches of grassland provide habitats that the little patches don't provide. You know, some critters need a big patch of grassland, and so it's actually a major conservation issue. Now here's another topic which is increasing, and I hope everybody can see the little white lines here, but this would be native prairie, one of those big patches. This is actually on the edge of the Great Sandhills. Well, it is native prairie, but I guess the point I'm making is, before we had all this oil and gas development, this would have been a ranch. It still is a ranch, you know. And one of the nice things about ranching as a land use is it doesn't require many roads, right? Often you've got kind of one major road to the yard site, and then some little trails out to fields and so on. So the road density tends to be low in a ranching land use. Okay, here's gas development. And you can see now there's roads all over the place. Every one of these well sites has to have a road accessing it, and then there are sort of more major trunk roads and so on. And so the density of roads in that piece of grassland has increased dramatically because of gas development. So that's another big part of the fragmentation picture, is the amount of road development associated with oil and gas development. Been talking about grasslands so far, but wetlands are a pretty important part of the picture in the prairies as well. And we had one pretty good study from Environment Canada looking at the trends in wetlands from 1985 to 2001, and basically the overall conclusion is a 5% decrease in wetland area and a 5% decrease in the number of wetlands. So, you know, and this was done by remeasuring permanent transects that had been established back there in the 80s to measure wetlands and measure duck populations and so on. So why is this decrease in wetlands happening? Well, here's the answer. This is an air photo, and you can see all these little wetlands. They're out in cropland, but every one of these little wetlands has a drain leading out of it, and then this is kind of the major drain here, and then there are little spur drains going off to these individual wetlands. Even this patch of native here has a drain coming out of it. So basically, artificial drainage of wetlands is kind of the main reason why wetlands are decreasing. And in the wet years that we've had in the last few years, of course, there's much more push to drain wetlands because farmers are losing a lot of cultivated land to flooding. Okay, so that's changes in the amount of grassland and the fragmentation of grassland. What about what's in the grassland? And here I think probably our second biggest threat after habitat loss is exotic invasion. Here's a patch of grassland, and this, I don't know if you can tell here, but the broadleaf grass here is smooth brome, which is a grass that originated in Eurasia. It's brought here as a forage grass, and of course a lot of people value it as a forage grass, but it's extremely invasive in our native prairie. Here's a list of invasive species that was put together by the Prairie Conservation Action Plan in Saskatchewan. And so we've got some grasses like smooth brome and crested wheatgrass and quackgrass, Kentucky bluegrass, a few shrubs, and then a number of forbs that are considered invasive as well. Well, we don't have invasion everywhere. It's kind of uneven, and here's one of the main reasons is that fragmentation that I talked about is one of the factors that contributes to exotic invasion. Now, this is a little study that we did at SRC, looking at some of these small remnant patches of prairie, and basically this is a transect from the edge of the prairie patch into the center. That's the edge there, and the vertical axis is the percentage of the biomass that's made up of exotic species. And so what it shows is that the closer you get to the edge of the patch, the higher proportion of the biomass is made up of exotics. So, the edge of the patch is probably a road or something like that. Roads are conduits for exotic species. When you look at a ditch anywhere in Saskatchewan, it's probably got smooth brome growing in it. So that road network out there is sort of like a super highway for smooth brome and other exotics to spread. And so the grassland that's adjacent to that road tends to be invaded. And then the further you get into the center of the grassland, the less invasion you have. And that's why these large patches, one of the reasons why these large patches have more value for conservation than the little fragments. Okay. Fragmentation contributes to exotic invasion, and soil disturbance does as well. This is a study done by Joyce Belcher in southern Manitoba, and they're looking at leafy spurge patches. Now, leafy spurge, of course, is one of our worst exotic invaders in the prairie ecozone. And they found, I guess, 83 individual patches of leafy spurge. More than half of these were associated with trails or fire guards or other linear disturbances. Okay. The second biggest category, it says disturbances caused by tracked vehicles turning, which sounds kind of weird, but I realized that part of the area they're looking at was the military base in southern Manitoba, Camp Shiloh. So I think that's tanks. The tanks do a big turn and kick up the sand, and that's where the leafy spurge patch starts. Only four patches out of 83 had no visible soil disturbance. So soil disturbance contributes to exotic invasion. And an obvious effect of exotic invasion is that as the exotics increase, the native species decrease. So I've got two different studies here that compare invaded, these are the red bars, and uninvaded, which are the green bars. And all these species on the left side are native grasses, which are abundant in the uninvaded and much less abundant in the invaded patches. And of course, in the invaded patches, it's mostly these exotic species like crested wheatgrass or smooth brome. Okay, well, another of the threats that has been brought up is the change in fire regime, and we know that under pre-settlement conditions, big, frequent fires were the norm for the prairies, and we have historic accounts like the Palliser expedition in 1857, where they describe these enormous grass fires. Okay, there were frequent fires, and they covered large areas. Art Bailey at University of Alberta made a very rough estimate of a fire interval of 5 to 10 years in their natural grassland. It's a little hard to do in grassland. You know, in forest, they use tree rings to get at this. In grassland, we don't have a direct measure like that. But nowadays, of course, fire is much less frequent, and the reason is all those roads and cultivated fields. Because every time a fire gets started, you know, it's got a good chance of running into a road or a cultivated field and stopping. So unquestionably, we've got much less fire out there in the landscape than would have occurred in the natural grassland. We do have fires sometimes. This is a big patch of grassland. There's a lightning-caused fire, you know, so it does still happen, but it's undoubtedly much less frequent than it would have been naturally. What are some of the effects of this change in fire regime? Well, especially up here in the aspen parkland, the effect that we see is an increase in woody cover. You know, so you think about that aspen parkland being a mosaic of aspen groves and grasslands. There have been quite a few studies actually that have shown that those grassland, or that the aspen groves have expanded and the grasslands have shrunk, you know, over the past century, and it's almost certainly related to this lack of fire. Here's one study from Alberta. They looked at the early land survey from 1903, 7% aspen cover, air photos in 1963, 52% aspen cover. So, you know, there's been a huge expansion of aspen related to this lack of fire. So here's a kind of a typical scene from a lot of our protected areas in the aspen parkland. You know, we find a wildlife parcel, or in some cases a provincial park. We usually protect it pretty effectively. And here's the grassland gradually disappearing under sort of a wave of aspen sprouts and also shrubs. So this is a big factor in the parkland. Another effect of the change in fire regime is probably higher grass production, because the research that's been done on the effects of fire show that usually you get a decrease in production for 3 years or so, maybe longer, after the fire. And I think you can see why if you look at the picture here. The unburned grassland has this thatch of litter. It's got the grass plants in the litter, keeping the soil cooler. Whereas the burn patch is, it's much more exposed to the sun. It's black, so it warms up faster, and so it tends to be drier. It has lower levels of soil moisture in the surface soil, and so production is usually lower. And it takes a number of years for production to recover to its former level after fire. So you think about the prairie being frequently burned in the past, it probably means that production was lower, on the average back then. Okay, livestock grazing, and I've got a question mark here. It's often one of the ones that's listed as a threat to prairie. Should we even think of it as a threat? This whole system evolved with bison grazing. And it's not as though we can assume that cattle grazing is heavy and bison grazing was light, because that's not true. There's lots of evidence showing that, at least in places, bison grazing was pretty heavy. There's I guess a big area of the central states that originally they thought was shortgrass prairie. It was blue grama, and then when the bison were extirpated, it recovered to mixed prairie, so basically the average level of bison grazing was heavy enough to control the composition of the grassland. So the natural grazing regime was probably pretty heavy in places. I think the biggest difference between the modern situation and the pre-settlement situation is spatial pattern. Bison grazing was patchy, both in time and in place, right? The herd came through, and just devastated an area and then moved on, and maybe it took a slightly different path next year and so on. So I think you had patches of heavy impact and patches of light impact, whereas our modern style of grazing, where we confine animals with fences and so on, tends to be much more uniform in its impact. Now, this is a kind of a neat graph to which I owe Barry Adams, thanks, showing that the recommended stocking rates on grazing land are actually more conservative now than they were in the early days. And the vertical axis here is acres per animal unit. So basically the higher numbers mean more land per cow or lighter grazing impact, right? So in the early days of, this is in southeastern Alberta, but mixed grassland, in the early days they were, I guess, over-optimistic about how many cattle they could run on this land, and so there was some extremely heavy grazing practiced, and then as the years went on, they saw some pretty bad results, and then there was more science about sustainable grazing practices. And through the years, the recommended stocking rate provided by government folks has changed dramatically to a much more conservative situation nowadays. So if you think about livestock grazing as a threat in a sense, it's a threat which we've controlled to a very substantial extent by developing good grazing recommendations. So, okay, here's another way of getting at this question is range health assessments. I don't know if you've been exposed to this technique that was developed in Alberta, and we've got a similar technique in Saskatchewan. But basically, this is a large number of range health assessments from Alberta, about more than 7,000 of them. And some of them came out healthy, some of them came out healthy with problems, some of them came out unhealthy. Overall, about 8% of them came out in that unhealthy class. So I guess that's one kind of indicator of how much of the grazing out there is what we would consider a threat to grasslands, and some small percentage. Another thing that's interesting about this is we look at the scores, and 10, 14, 20% unhealthy in the parkland and the foothills fescue. Higher percentage of unhealthy in the moister ecoregions. And I suspect that the main reason for that is exotic invasion. Yeah. Higher rates of exotic invasion in the moister ecoregions. Down here in the mixed grassland and the dry mixed grassland tends to be more natural, and so it comes out healthier. Okay, here's another one, urban encroachment. This is my colleague Bob Godwin out doing vegetation sampling with people watching from their backyards, basically. So this is Saskatoon Natural Grassland is a little urban prairie preserve. It's only a couple of miles from here. It was slated for development, and turns out there was a bit of grassland there, and so people got together and mounted a bit of a campaign. The slogan was "Rescue the Fescue," because there was some fescue grassland there. So they put aside, I think it's 13 hectares or something like that, a small patch. It's a nice place though, and of course now it's got houses all around it. How significant is this? I don't know. How often do we run into this situation where we've got grassland right adjacent to urban development? I'm not sure how important this is. But another major factor here is this idea of ex-urban development. The idea of ex-urban development is we've got urban development, which is high density. We've got rural areas, which are low density. and ex-urban is somewhere in between. So basically it's that zone around every city where there are acreages and small rural residences. In the U.S., it's increasingly being considered a major problem in terms of the amount of grasslands being affected. From 1950 to 1970, increased by 170%, by 90% from 70 to 2000. And lots of research, and here's an interesting study from Colorado showing that if you think of three classes of land use, you've got protected areas like national parks, for example, you've got large ranches, and then you've got this ex-urban development, small rural residential development. Well, if you look at it in terms of biodiversity, the large ranches are actually similar to the protected areas. You know, so a ranch is just about as good as a national park in terms of conserving biodiversity. Whereas these areas that are divided up into rural residences have a number of negatives about them that are, you know, bad for biodiversity. For example, higher population of dogs and cats. Why is that a problem? It's amazing how many birds get preyed on by domestic cats. You know, so. And then you look at the birds, things like magpies and starlings that are well adapted to human settlement are much more common in these ex-urban developments. Whereas some of the species of conservation concern are less common. Okay, I've got to show this picture here. This is just east of Saskatoon. First question I should ask is, does anybody live here before I say any more about it?
Say it again.
Yeah. Okay, and I can't really point any fingers because I personally live on an acreage too, you know, so everybody wants to, right? So, but this is out east of Saskatoon. It's where the highway kind of rises up over the Strawberry Hills, and you can see that on the flat land on either side it's cultivated, but there's this belt of hummocky moraine north-south that it was too rough for cultivation, you know, so that's why it stayed in natural vegetation, aspen parkland with pesky prairie. And so, you know, when people were looking for housing development, okay, how many people want to live in this wheat field compared to how many people want to live in this nice patch of aspen parkland, right? So that's where the housing development is on this stretch of aspen parkland, and it's, you know, it'd be a nice place to live. I'd like to live there, but you know, at the same time, that's one of the things that's happening to some of our remaining grassland. I'm sure you could find examples like this around any major city in the Canadian prairies. The result of all these things, we've talked about cultivation and fragmentation, exotic invasion, changes in fire regime, urban expansion, and so on. Here's a good indicator. There's a set of bird species that they refer to as grassland birds. We have this breeding bird survey that's gone on for decades, pretty good source of data. And overall, grassland birds have been declining. What's the time span here? 1970, I think, down to the present. You know, persistent long-term decline in grassland birds, and I expect the same could be shown for other types of biodiversity. So I think there's a presentation tomorrow about biodiversity, I believe, and so that's that leads into that, I guess. So, okay, thank you.
If there's any questions of clarification, or you just want to check on something that, well, it's fresh in your mind, do you have any questions for Jeff?
Yes, I was interested in your comments about burning, and that you say it reduces productivity of the grasslands in this region.
Yeah.
Because I'm from Kansas,
oh, yeah.
and it's just the opposite there.
Right.
When they burn there, it greatly increases productivity. So that's interesting that it's just the opposite.
And that's a tall grass situation, is it? Yeah, yeah, yeah. I think, I think the results I was referring to are mostly from our drier grasslands, which is sort of a dry type of mixed prairie. But
yeah, just a comment. We've done a fair bit of recovery monitoring in Alberta. Usually it's to do with litter removal. It depends on the years it takes to recover the litter. It's about 5 or 6 years in the dry mixed grass. Shorter time than the grass.
Yeah. So the moister the climate, the more, I guess the less impact. So, yeah.
Do you think that the same trend from burning would be evident in something like species richness, or, you know, because sometimes if you say productivity falls, people forget that maybe productivity falls but diversity goes up. Do you think there might be a compensating factor there?
Yeah, well, I mean, like the longer it goes unburned, the more it tends to be dominated by a few taller grasses. You know, so you know, I think there are probably lots of situations where burning increases diversity in the sense that you've got niches opened up for some of these small, you know, forbs and smaller grasses and so on, and annuals, I guess. You know, so.
Is there any work on that in Saskatchewan that you know of?
I'm not sure. I haven't seen it, I guess, but there may be. Oh, Barry?
Just, you know, your comments on fragmentation, Jeff, I mean, I think that's where our kind of anxiety about the future is for Alberta grasslands, especially with our industrial load that we have on the landscape. In the land use framework, that's one place where, unfortunately, a lot of this analysis hasn't seen the light of day yet. But it's one place where we're starting to look at actually using cumulative effects metrics to get a handle on this. And just complementary to what you showed, one thing that stuck in my mind was looking at we call it the dry mixed grass and the mixed grass, which would be your mixed grass and noise, same thing.
Yep.
We, that grassland, most range site types were, at the present time, if we looked at all infrastructure, pipelines, well sites, and things that we have records for, the current edge density is at about 1 to 2 kilometers per square kilometer. And if we continue on at business as usual for 50 years, then almost everything is in the 3, 4, and 5 kilometers per square kilometer range. So
That's kilometers of edge, like
kilometers
the edge of habitat. Yeah.
sometimes called road density,
Yeah.
but this includes other things.
Right. Yeah.
And so, just as you described, if everything that we do wrong along those edges in terms of invasives and moving stuff around, then, you know, that just contributes to that loss of the degradation of the fabric of the earth.
Yeah. Yeah, and there's lots of research about animal use related to those, even just little trails accessing gas wells can, reduce the use by certain species, and so you get kind of a zone on either side of a trail that's got reduced populations of certain species and so on. So, yeah.
I think we'll hold any other questions into panel discussion, but we have a little token appreciation, Jeff, for
Thanks, Brad.
excellent talk.